This morning, we are transitioning. We kind of transitioned after yesterday afternoon already, but we're transitioning to more of a kind of hackathon, kind of focusing on code, focusing on hacking kind of mode. I'll be doing a bit of kind of explaining things by looking at Polkadot SDK and so on. I'll be doing some of that. And then Ankan is going to do like a small lecture on migrations this morning, but we will probably start already hacking again on the assignment already in the morning, and then we'll continue doing that in the afternoon. I encourage you to put questions in the Discord. Maybe Cisco can like collect them a little bit so that we have a bit of a backlog of questions to go through, and maybe Cisco, you can even like prioritize them what you think is like useful to go into. Yeah, so that we have good material, so that this is useful for you. And if at some point it's no longer useful, then you get to hacking on the assignment stuff. But we start with frame extras. So this looks like slides, but it's just like a jumping off point mainly. The frame has quite a few kind of corners and features and so on and so forth, and this is just a few things that we want to talk about. Some of them we touched already a little bit, but we want to get a tiny bit deeper, just explain them. You're very encouraged to follow along. So mostly I'll be looking at Polkadot SDK, and then I think I expanded the assignment, so that's another thing that you can do. I basically did this. Can you see that? Is that big enough? Yeah? Or should I zoom more? It's good? Okay, cool. All right, so you have the cargo expand command. So I did. So you want it bigger? Okay, cool. Right, I used the cargo expand here. You can do the same if you want to follow along and check the things. And then the other thing is SDK. And then I have one more thing that I'll show you in the Akala repo. Cool. So you're encouraged to follow along. Runtime call filters. I think we've mentioned them already a few times. And I just wanted to show you that they exist and what the syntax is. So you have an example. Just very simply. So the default way of doing this is zoom. Like this? Yeah, that looks good. So base call filter, you just define a struct. You can name it whatever you want, but this is the usual name. And then actually this is one of those, the get trait. The get trait, there's nothing really actually substrate specific or frame specific about the get trait. And similarly for the contains trait, it's just one of those small utility traits that is kind of peppered all over the repositories, just because it's useful and you could use in any Rust project. There's nothing really specific about it, and it's just this contains, and it makes for a nice. It's used in a few places to have these kinds of filter firewall kind of type things. And here is the base call filter. So this is just one example from Akala parachain, and they do this kind of matching on the runtime call, right? You just get the call in, and you can match on it and go like, if it's timestamp, then we always want to let it through. If this is a transaction, this is a pallet, if it says that we're paused, then we don't allow any other call, right? And then, if it's the Polka.xcm pallet, then we match what it is, right? And say like, okay, we don't want to allow teleport assets, we don't want that extrinsic, and so on and so forth, right? So it's just sort of an example of a fairly extensive call filter that you might see in the wild, and that you might also add yourself. So we had the disable call in the runtime, in the construct runtime macro. That is very sort of broad, the whole palette. This is, like a fine-grained, I want to disable particular extrinsics. This is potentially something that you might use after an exploit gets known, right? You do a quick runtime upgrade that filters certain calls, or it's something where you progressively unlock your chain, right? You have a few pallets already in because you want to configure them in the Genesis config, right? You have the data already in there, but you don't want people actually using them. You might use this in order to limit the access. And I figured it might be nice to have a quick look at where this is used. So we have the base call filter. Oh, yeah, here. So configured, it is in frame system, right? And then where is it used? Works. Oh, I set a bookmark in the previous file I generated, and so now it's gone. Okay, we need to search. Return call. There we go. So, what is this? So you understand, right? Cargo expand basically takes the Rust code that is generated by the macros, and instead of compiling it, it outputs it as code. So this is roughly what ends up sort of at the actual compilation stage of the compiler. Not 100%, but roughly. So you can see like, oh, what did my macro actually create with the code I used it in? And so you see some of these like patterns of like, oh, we have this like hidden includes blah, blah, blah thing, but in the end, like, okay, it's dispatchable, it's like a trait. And we have our runtime call. We talked about outer enum, right? Like this is where all these types show up. And then here is the dispatch, right? The runtime call dispatch. And you can actually see the implementation here of how is dispatch implemented in your runtime. And what it does is it calls filter call. And then once it has the call filtered, then it does a dispatch bypass filter, right? First it does the filter, then it does the dispatch without filtering. And then we can look at, oh, well, what is filter call? And then filter call is part of the origin trait implementation. Runtime origin. And we match on the caller, and if it's root, we actually don't filter. So that's an important thing to know, right? Like your root origin can do whatever it wants in the chain. That's part of what it means to be root. And if it's any other origin, then we filter. And you can actually see that the filter is configurable. Like I guess he has reset, and reset resets it to, where is it? Here. Right? We have runtime as frame system config base call filter. That's the one that we saw in the Akala runtime. We saw that type. It uses that as a filter. I guess it uses the contains, but whatever, right? It uses that call filter, configures it, and then it's used here in our filter call. And so it can be a little bit tricky to find the right name of the right function or something, but in principle, if you want to know, oh, how does this flow or something, the expanded files are a very good way of seeing like, oh, what's the actual code flow? So you don't necessarily need to ask an old hand to learn this. Although, of course, you're encouraged to do that, but yeah. We have a question there. Cisco, behind you to the right. Iman has a question. Oh, you don't have a microphone. Do we have the microphones there? There's one here. Okay.
Just like I feel like I'm confused. Do we, when do filter, these functions name are already known, or like we just overriding, or we can add whatever function, and if function name I mean, and if we are adding our own custom function name, how the runtime would know this is where we will be injected in certain phase.
So this filtering is based on the call. So the call is part of your runtime. It's generated as an enum. So it's not string based, right? It's enum based. It's like an amount. So that's what you filter based on. So how do you know? Well, what is available in your runtime is defined by the runtime call. And so that's what you filter on. So there's never, this mismatch doesn't really exist, except if you decided to store something in storage, right? And then what's in storage and what's in the code defined could kind of diverge. So that could happen. But as long as you just work with stuff in the code, it doesn't go, the mismatch shouldn't be there because it's.
I mean, for example, function contains and then the parameter. This contain I have to whenever I want to do filtering based on it is there or not, I have to use this word, the function name, just to, for me, it's I'm overriding the function there.
Overriding the function there. You're implementing a function, you're implementing a trait. I'm a bit, can anyone else rephrase the question in a way I understand? I'm very sorry.
No, because I'm confused. So my ability to phrase it in a good way is not the best. So my question again is let's assume I have a palette that do the filtering things, okay? And I'm creating my own custom palette, and I want to do my own filters.
You want a palette that does filtering?
Yes.
Okay. We actually see something like this here as well. So this comes from a palette called pause transaction filter. So you would use this exact pattern if you had a palette that wanted to filter as well. In this particular case, this is not so much about filtering here right now. Well, I don't know. Maybe they have an actual filter in there as well. But it looks more like, oh, is this paused or not? Oh, yeah. I think if I remember correctly, I think I saw this palette once. I think you can add palettes or calls that you want to pause, and you basically say, this palette, I want to pause it, and then this is checked in this contains implementation.
Okay, my second question, this is how we are implementing filters. We need to call these filters somewhere in the runtime, or it's automatically injected, because it doesn't make sense for me.
Yeah, there's no macros involved here. This is all just Rust code. This is just the only thing that comes from frame really is that the runtime call type, right? This enum, and then that frame system has the base call filter as a configurable thing. And then the only macro generated thing, I was showing you the implementation, how this is actually called under the hood. But in terms of your code, this is regular Rust, right? This is you define a struct, you implement a trait for it, and then there is an associated type here. Right. Call filter equals, right? There's an associated type that you set. In terms of what you do, there's no macros involved. It's just plain old Rust.
So if you use the base call filter, it will be taken into account. It will do filtering. But if you build it, because it's implemented on the system palette, but if you implement your own filter, you need to figure out where to call the actual filter. It won't be called magically.
Okay. Cool. Anything else about the call filter? I think not. Just a quick note, right? I already mentioned the origin trait. It's a trait. You'll need to check if you want to work with the origin more, because you're implementing something a little more sophisticated. Might need to import the origin trait, right? And it has a few things that you can do it. You can For example, you can get the caller, yeah, convert into caller. Cool. If there's no more questions about the call filter, I would move on to the next one. Account reference counters. Yay! So we already touched this a little bit. So actually, let me show one more thing. Frame system. So we touched on this a little bit, but I feel like this is a good point to explain it in a little more detail. So one pattern I actually really love is that kind of software patterns are kind of fractal. So in Rust, we have this nice thing where the compiler basically manages our memory for us if we give it enough information to do it, right? Oh, this is a box. Okay, you know, as soon as the box smart pointer goes out of scope, it will clean up the memory for us. Oh, this is on the stack, cleaned up. Oh, this is an atomic reference counter. Okay, if the reference goes to 0, it's cleaned up. And the funny thing is, like, if you go one level up, you always end up in very similar problems. So in our case, it's like, okay, we have a struct defined, and we store that struct in a database, and we also need to know when we can remove it, right? Same pattern. But the Rust compiler does not understand about account IDs and the database and so on. It's quite difficult to kind of tell the type system about this. So we need to manage it ourselves. And so that's one way that I think about this. It's like, oh, this is the same problem, the same memory management problem we had down below, just one level up at our sort of business logic kind of level. So with the accounts, right, we have this problem where if we just allow anyone to create accounts and we just keep them around, the database will fill up, and at some point, our state will bloat. And resources are scarce because we need to duplicate it to the whole network, or like to all the validators anyway. And so we want to limit it. And so that's why we want reference counting as a method of keeping track of who needs this account to exist, and is it worth keeping this account around? So those are the two questions that this system tries to kind of help answer. Who needs this account to be around, and who kind of guarantees or makes it worth it to keep that account around? But we end up with 3 values. So the consumers are the ones that are like, I need this to be around, right? A consumer is someone like, I want this account. So what is an example for a consumer? I think we covered this when we talked about holds and locks, I think. And I would expect that, let me see if it's also in the, might be even in my bookmarks. Nope. Nope. Unfortunately, it's not. That's a bummer. No, okay, then it's not. But yeah, so in if we set a lock, right? If we're voting with the account, right? We want the account to stay around. So that's an obvious case where we would increase the consumer count, right? Oh, I just put a vote somewhere. We lock some balance for you. We want the account to stay around. We can't just have it disappearing on us. There are other reasons why you might have this, right? You have a position in a DEX. You have whatever it is you're using the account for, where some functionality stays around for a little while. You have something in storage, it's related to the account. You want to make sure that the account stays around. So that's the consumers. I think it's very straightforward in dependency in. Now, just because you want the account to stay around doesn't mean it doesn't necessarily mean it's a good enough reason to keep the account around. That makes sense. So what is an example? You could think of setting a lock that is pretty high, that's higher than what's actually in the account. So just because you set a high lock doesn't mean that it's worthwhile to keep the account around, because the account, like, it might have less than the existential deposit potentially. So this doesn't happen in our system, just sort of conceptually. It's a little bit abstract, but I hope you can understand this. Like, what determines whether it's worth it to keep the account around is not how big the lock is, so how many consumer references we have, right? That's not what determines it. What determines whether we want to keep the account around is the account involved in something that's worthwhile to the chain. And in our case, that's usually the existential deposit. That's one of the key ways, but that's not the only way. And that's why this is a flexible system, right? You can have different ways. So I want to show you some ways where we increase the providers. So for example, there is a Genesis config for the session palette. You can't see it well here, I think. Can you? There, let me. Oh, come on. Okay. Yeah, we have the session palette. And so the session palette is involved in the active validator set, and like kind of who gets to build blocks and stuff. And so we really want there to be keys in the session palette. As one of our key safety security concerns as a chain is we want a validator set, non-malicious active validators. And the session palette, I think, is mostly not involved in making sure that is the case. That is other stuff that does that, but it manages the session keys that are associated with that. And it has a Genesis config where initially for when the chain boots up, when it starts, it provides some session keys. And so here is an assumption that we make in this palette where you might configure session keys for an account that doesn't exist, right? And in this particular case, the programmers made the decision, okay, it's important that we have the session keys, and it's more important than leaving a few accounts around that don't provide any value in terms of existential deposit. All right, the session keys are super important because we need them to run our chain. So what they do is, okay, they say like, hey, we just increase the providers. Having session keys for an account is a good enough reason to keep them around. Does that make sense? Yeah. If you build an NFT first chain, yeah, 1 second, and then there's a question there. You also had one? Yeah, okay, 1 second. You could build an NFT first chain, yeah? Where you say like, account balances we don't care about, we'll figure it out somehow. And the main thing that users have are NFTs. You could say certain types of NFTs, like we talked about gift cards, right? Like, so part of the NFT chain are these gift cards, and gift cards have a certain amount of value. So any user that has a gift card, they purchased it in a store, any user that has a gift card, that's good enough reason to keep the account around. And so that will increase the provider count if they have that NFT, that gift card NFT. Make sense? Okay, questions? I think first in the front row.
Yeah, so I wasn't aware of the providers. I thought the ED was the only thing that mattered. Which one has precedence? If I have 1.1 DOT on my account, but I never use it, is there still a chance it could be reaped if my providers are 0?
So the thing here is, it's any provider, like you just need any provider. The providers is basically, is there good enough reason to keep this account around? If you have your ED in the account, good enough reason. If you have this here from the session key Genesis config, good enough reason to keep it around. So it just needs to be higher than 0. Okay. So this is very similar to the reference count in a reference counter in terms of memory management, right? If the reference counter in a memory management system hits 0, that's when you deallocate the memory. And the same here for the account. If the provider count hits 0, that's when we deallocate. So you can have a provider count of 10,000, the same as if you have a provider count of 1, in terms of like, does my account stay around? So yeah, as long as you have the existential deposit, you're fine.
Yeah.
And just to be clear, in the other example, even if the ED falls below 1, it's not guaranteed it's going to be reached. There might be other reasons why it could stay around.
Exactly.
Okay, thanks.
Exactly. So the actual check is there a provider count higher than 0? There was another question, or did it clear
No,
itself up?
it's
Okay.
resolved. But another thing I want to say, so just to very simply answer the thing about precedence, providers and consumers is everything that matters. Then the ED is just a thing that gives you a provider. There could be other reasons, just as this one. But the providers and consumers is the actual thing that takes precedence. So you can have accounts that don't have an ED because they have another provider. Just food for thought, because it might be useful to create accounts that do not need an ED.
So one other use case for accounts that don't have an AD would be these kind of bucket accounts where you gather funds, right? So that's a case where you, as a Palette runtime developer, would be aware of this, where you go like, I have this treasury, and my treasury, it should keep funds. And I know I want the treasury account to stay around, right? I use it for my, for my needs in my Palette. So I don't care whether, there's like, I will, and so what you might do is you might just increment the provider count on the treasury account, because you're like, yeah, that one should exist. And there's a limited amount of treasury accounts that will be around, probably.
This isn't really a question, but apparently Moonbeam doesn't have existential deposits. So I guess it's possible for a parachain to say that we're not going to have an ED.
It's possible for a chain to say we're not going to have an ED. Yes, that is possible. Yeah. Totally possible. Cool. And so now the consumers, let's go back one more time to that. What is the consumer account? The consumer account is basically a lock that keeps the provider count from going to 0. It's like, it's a, hey, I'm still using that, right? So if someone wanted to transfer all their money out of their account, but they still have a consumer lock on it, right? They still have the consumer account because they have open vote or whatever the thing is, right? They can't transfer all the funds out because the provider account, hinges on their existential deposit. Make sense? And so the system will forbid them from transferring the funds because there is still a lock on their account. If they have this, actually, if they have if it's a from the session keys palette, there is a provider account. Depends on the implementation, of course. Like maybe the transfer will check the lock, the freeze on the on the funds, so it might still not work. But in principle, if someone builds a palette that just goes like, oh, if an account interacts here, I'm going to increase the consumer account, then in principle, the person can move all of their funds out. Yeah, so let's say the voting, that's not a voting thing. Let's say there's a raffle, like a lottery type system. And in order to enter the lottery, you register yourself, and then that bumps up the consumer account because they need the account to exist for the lottery. Let's just say that's the case. Let's don't worry about whether it's good design. So the lottery palette says, okay, we increased the consumer account because this account was registered with us. If they have a provider account here, because of the session, blah, blah, in the Genesis config, they might be able to move all of the funds out of their account, but their account will be kept around, so they're fine. The consumer is happy, the lottery is happy, because the account is still around, and they moved all the funds out. Yes? Or it's a complicated hypothetical, but I wanted to just sort of illustrate the. Let me go through the bookmarks one more time. So here's an example of consumers. We have set except ownership for a collection, I think. This is uniques, so this is NFTs, right? And so if I accept, right, I'm the origin, turns into who with ensure signed. And then if I accept the ownership, then that means my account needs to stay around, right? For example. And this could be our example. So you accepted the ownership of an NFT collection, right? And the NFT collection doesn't care about the existential deposit. It just cares about the account staying around. And then here you see the other pattern that you as palette and runtime developers will need to care about, which is, except for exceptions like the session palette we just saw, what we want to do is we want to have corresponding increasing and decreasing. And you want to make sure you want to have tests, maybe even property tests, right, in your system that make sure that you never try to reduce the consumer count below 0 or like below what you increased it to, right? If you bump it by 1, you have some corresponding operation to decrease it by 1 and vice versa to make sure it stays consistent, because otherwise the system doesn't work. This is contracts. It's another example. Each contract is an ink, right? Or not, no, sorry, it doesn't have to be ink, it's a contracts palette. Each contract has an associated account ID. And when we instantiate the contract, we say like, oh, this account needs to exist because the contract exists. And then when the contract is removed again, we can decrease it and we can wipe it. Providers usage. So this is try mutate account in the balances palette, right? This is the ED thing, right? The existential deposit corresponding thing. This is where the magic happens. Yeah. Yeah. So here actually we have the existential deposit does provide, right? This flag. It's like, okay, is the account, the free amount in the account, is it greater than the existential deposit? And if it was not beforehand, but now is, that means we put some tokens, for example, into the account. It was 0 before, and now it's 1 dot. So we increase the provider, increase the providers. And then we have the other one, sort of the reverse direction. Cool. All right, so you've understood, I hope, consumers and providers. And now the sufficients. So the sufficients, I think I have them somewhere in the bookmarks. Yeah. So I think they came in later as an addition, and the idea is the following. There might be cases where something in the system is self-sufficient, as in it provides its own kind of reason for existence. Again, for example, again, the NFT example, you might be like, oh, if you have any NFT, that's good enough to keep the account around. But, you know, some NFTs are kind of bullshit, so we're not going to allow you to, for example, vote or do other things in the chain based on just owning an NFT. It's not good enough reason that you can depend on it. It's sufficient reason to keep your account around for now, but it's not something you can depend on. So that's why it's not a provider, it's a sufficient. Yeah? Or you have some assets and we say like, oh, that asset is sufficient. That's something that if you work with the asset hub, you will come upon this. This is like a flag for an asset on the asset hub is the sufficient flag. So this asset is sufficient reason to keep the account around, but it's not sufficient reason to have other palettes depend on the existence. And so that's what the sufficient count is for. It's as the name says, it's self-sufficient. It's like, yeah, we'll keep your account around, but as soon as you get rid of the NFT, your account is gone. As soon as you get rid of the asset that you're holding here, your account is gone. So it's actually maybe a little bit closer to what you would have expected in terms of kind of reference counting, memory-like thing, right? As soon as the count hits 0, the thing is gone. And it doesn't have the complicated split into like dependent and providing, you know, like consuming, providing thing. So now what does that mean for you? In your palette, if you want to do something with an account, you might think through, like, okay, so I have some associated data maybe that I'm storing for the account, or I have something related to an account I'm doing. What does that mean for the existence of the account, right? And so if you just store some data, I would say that's a consumer reference, right? It's like, I have data associated with the account. I need a reason to keep the data around, yeah? If you mint tokens, normally you would use the minting of the balances palette and so on, and then it already does the provider stuff for you. But you know, if you write a palette that, you know, is a new token palette, if you write the competition to the balances palette, right? You might get to a point where you're like, I'm minting some tokens, so I'm creating a reason why this account should stay around. So then you might increase the provider reference or the sufficiency count, depending on whether you want other palettes to rely on the existence based on yours. Cool. And then a lot of the time there are tools like if you put a freeze, right? A lot of time what you want to do is, I want to make sure the account doesn't go below a certain amount, right? So you put a freeze on it, and then in the background, the freeze will take care of the consumer stuff, and you don't actually need to worry about it yourself. So it depends at sort of what layer of abstraction you're working. This is relatively low level of abstraction. So I would say first go to like, can I do what I need to do with a hold or a freeze on the account, right? If you're working with account funds of an account, can I do this with a hold or a freeze? And if the answer is no, then you will go for this stuff. I think I would leave it at that, except if you have more questions. Yeah.
I was wondering, from a UX standpoint, is there a good way for the user to see if there's any, providers or consumers on their account, or if they have any sufficient assets? Because I haven't noticed it in any wallets, but I haven't really been looking for it.
Yeah. So this is not a user, like this is not meant for end user conception or looking at. What the end user will see, they will see something like, oh, I have frozen, like, right, my account is, some of the money in my account is frozen, and that's what they will see. And then they will know, like, I can't just move everything out of my account because it's frozen. Or like, oh, I voted somewhere, right? So the application will show the actual thing that the user did or is involved in, and not the reference count. This, again, this is low-level stuff. This is, you need to know this, or you might need to know this because you're working under the hood. The user does not. And I mean, of course, you know, you have the storage. Of course, in principle, if you really want, you could show counts. But I don't think it's a good idea. Cool. All right. That's count reference counters. Palette instances. So I think I'm going to start with a motivating example. Why palette instances and what they are. And you can see it here, actually. Maybe one more bigger. Whew. So big. Much big, very zoomed in. So you see here an assets palette. And you see a foreign assets palette. And so this is the asset hub. This is the asset hub West End, but applies to all the asset hubs, where you have two kinds of assets. You have the local ones, where someone goes to the asset hub and says like, I want to create a token. My token is going to be the PBA token. It will have 10 trillion digits or whatever. And we need to track those, and that's why we have the assets palette. But then what also happens is that teams come in and go like, oh, we want to register our native token on an exchange. And the standard way of integrating, as far as I know, that's still policy, is to integrate through the asset hub. Because there's like a flow for the exchanges to integrate with the asset hub, and it's straightforward. So what they will do is they will teleport their token, their native token, into the asset hub. But we don't want to mix those teleported in tokens with the tokens that were created on the chain. We want to handle them slightly differently. So what we need is we need another kind of namespace, another kind of separate asset tracking part of the starch. And for ease of use and for simplicity and so on, we have a second instance. And so that's why we have this and this. And you can see, like, if you look at the foreign assets here, at the config, of course, it's not that easy. Oh, come on. Was that it? Yeah, right, foreign assets instance. Cool. So we implement the config separately for these instances. And you will see that we have something interesting here, which is the asset ID is an XCM location, which makes sense. It's a foreign asset. It comes in from external, right? So the asset ID is different here than wow, there's a lot of assets in this mix. Did I miss it?
Yeah, it's the trust-backed. Yeah, one. And that asset,
here,
alias
trust
is just
back
a,
assets.
yeah, that
Okay.
alias is just a U32 or something.
Okay. So we already see you can make a PR if you like, because the instance is renamed here, but the name is not used down in the construct runtime.
Yeah, you cannot use in the construct runtime. I think you cannot use aliases.
Aliases on
You need to say, because if you see there, it says palette assets instance 1. But
Yeah.
if you go to construct runtime,
yeah,
it's actually only instance 1. It's not getting it from anywhere. It actually just needs the token instance 1, and then it will magically figure out where it lives.
Limitation of the construct runtime macro.
Yeah, it's just one of those things that we want it to be common Rust, but we still like help you in a way, and it ends up being like counterintuitive.
Cool. Thanks for the look behind the curtain. All right. So trust ID. Well, yeah, no, we can look for that one. But like what will happen, right? It will be a different type. It's from parachains common, and it's like it will be like whatever U64 or something. Feel free someone to look it up and let us know what the actual type is. Probably U128, U64, something like that. So the different instances will be configured differently. They have their own config. They have their own storage. So how does that happen? How does that work? Well, this is how it works. We, again, as usual, use types. All right? You saw the generic, like it's a generic, and you can pass the instance 1 thing, and it's just a flag. It's just an enum. It just, yeah, I think it's not even an enum. I think it's just the type, and it's just a name to distinguish between the two, right? It's just a little taggy thing that then tags the config and tags the storage, right? The config, the storage, and tags like here's the implementation. You just tag all the different. The event is tagged, like the error, right? You just tag all of these, in your palette in order to make it compatible with the instancing. And then what you can do is you can have more than one in your runtime, which can be very, very useful. Any questions about this? Your mind was just blown. No, it was one of the tools that you have as a runtime developer. Cool. That concludes the frame extras, I would say. Let's give the Wi-Fi. Oh, can I have it? Let's give the Wi-Fi one more try. We'll see whether it works. Otherwise, I go back to the phone. Let me know if this stops working without me noticing. Okay. So we have a bunch more time before the lunch break. About hour, 20 minutes. And I would do some more live coding. I think we haven't done much for the treasury or the free transaction. So that would be an encouragement. Maybe if you are working on those, you feel called to ask a question. Any confusions, burning questions, I'm up for it. And then we can write some more code. If you've seen something in a lecture and you were like, I wonder how I would actually use that, this is the chance. Sorry. Otherwise, I might write a benchmark. Oh yeah, for a question there. Do I have a microphone? I think there should be one where I used to sit over there if you're willing to grab it. And one of the other there. Yeah.
Hi.
Hi.
So I think we didn't have this like showing how to get some data actually from the palette, like actually as a return without event. Can it be done? Or
Get some data from the palette without returning an event.
without emitting an
From the
event?
outside, like a
Yeah.
Like
So
an app?
people spend their weight tokens to get some data, right? Or it would be free.
Are you asking the context of the free transaction or what way you?
No, any
No.
context.
Any context? People use their tokens to get some data.
Or they don't. Like maybe you could elaborate on that. So
I don't understand the question yet.
getting data from the palette, like for example, I am user, I have multisigs, I want to check which multisigs are mine. For example, just like that.
Which multisigs are mine?
In this case, we couldn't track that without
Yeah.
iterating, but something like that.
So the first answer to your question, I think, is the data is readily available. Let's see if I can spin up an Omni node here. Omni node. Dev. Okay. I don't have a chain spec, do I? No, I don't. Build release. Yeah, that's going to take a second. Okay, maybe in a moment I can show you, like you can use the Polkadot.js or other things, other libraries and UIs and so on to just check the storage. So that would be one way. So if you don't want an event,
so we
and
can just read the storage, and
yeah,
we can
you can
read
just
all
read the
keys
storage.
from it, right? Like if it's a map.
Yeah, if it's a map, right? Yeah, you just read the storage. Yeah.
Okay.
So you can there's under the hood the different nodes, including the Omni node, would have these RPCs that allow you to read the storage.
Okay,
So you give it keys and values, and then
yeah.
And there's metadata that sort of informs how they are encoded and stuff. Yeah. All right. I'm going to check real quick what the current state on view functions is. If one of the instructors wants to tell me, we can also. can also tell me. The current state on view functions. Huh? No, whether they're in already. So I guess by saying like creating a view function, I guess they already exist. Yeah, no, okay, all right, cool. Then that's not. I guess it's a good thing for people to know that there's this version of just checking the storage, and then a thing that's in development is nice. Okay, support has landed, and then the current process is adding it for the frame palettes. That might be a nice project for after the PBA to add some view functions to some of the palettes, the existing ones. Okay, more hacking ideas, questions about how to implement something, how to use some APIs. Is everyone firm on how to use the fungibles? Do we have clarity on that? That would be Treasury, I guess, would need to use the fungibles APIs. You guys good with that? That's a no? Okay, all right. Does that imply that you would like me to see implement something with the fungibles? Okay, let's do some of that. We are in the Treasury. Cool. Let me just check the, if you're free, if you see a microphone somewhere, grab and make a question, sort of make it a concrete ask. Otherwise, I'm going to check what would be a good idea to do for the multi-token Treasury. Access, spending tracks, handle allocation of funds, handle cases where there's not enough. There's the different assets.
Can you show some hold and release stuff with fungibles?
Hold and release. Okay. So yeah, let's say we have a Treasury account. I think we have, yeah, nice. We have an account ID here, right? And we already have some funds in it. And we want to kind of, we want to register a spend. So we'll do that with a hold to pre-register a spend. So maybe, let's do some test-driven development. And Treasury tokens are held on registration. I'm not saying this is how you should exactly implement your thing, right? This is just a scenario that's related, and it might make sense. Smooth, advanced suggestions, cool. Test. We might need to initialize some stuff, some balances, we'll see. Okay, so what we want to do is we want to call Treasury register spend, and well, we'll have runtime origin signed 1, sure, and then we will want to register an amount. Because it's a multi-token Treasury, let's use the assets. Let's actually make it fully generic and be like, okay, we can either do native tokens or an asset. So we'll have an option, and we'll have some asset ID here. And then we have some amount. Amount equals 100. And then we want to then check later on that assets on hold, I think. We can check the API, what it actually is. Mutate hold, inspect, balance on hold. That's probably what we want. That's not quite what we want because okay. But it should be the same API. We want the other one, balance, because we're working with assets here. So we want the fungibles, this one. So asset ID, reason, and who. So we give the asset ID. The reason will be spend registered. And who will be our account ID. Cool. And then the amount on hold should be the amount. This one, of course, should be assert OK. Oh, that's fine. Okay. So we want to register a spend, and then we want the balance on hold for that asset ID to be the amount that we just registered. I think that might be the test already. We'll see. Maybe we'll tweak it a little bit later. So we want a new extrinsic called register spend, origin, the usual, T, and then I've already forgotten our signature. It is asset ID and amount. Okay. I think the asset ID is probably asset ID off T or something. Yeah. And then amount. The amount might get annoying, right? Because we have this is one of the tricky things, because we have native balance and fungibles, and that means we have asset balance off and balance off. I would be inclined to just do a where clause. The instructors can yell out in pain if they think this is a terrible idea of what I'm doing here, but I think let's do is type. Is better is type or from and to. So what am I doing here? I'm saying I don't want to have to deal with having two different balance types. I'm just going to assume that for this palette, the two types are the same. Well, not the same. They're convertible. So that means that here I can say balance of T. And then I can do, sure, 2 equals ensure signed origin. And then if let sum asset ID equals maybe asset now we have an asset ID, right? So now we would want to use fungibles, I think it was called, right? It's in the mutate. Fungibles, mutate, hold. And then here we have transfer on hold, transfer and hold. We don't have put on hold. No, hold. Super easy. Cool. We get the asset. Beautiful. We get the reason. For the reason, we'll have reason spend registered, which we still need to pass. We need an account ID, so we do ref who, and we want the amount, which is going to be our amount. Look at this, beautiful. Okay, turns the result. Let's do a format. I hope after an unexpected colon. Where? Ah, that one was not necessary. Cool. We could add an event. Right now I'm going to focus on the test. So register spend with some asset ID, and we need to add the reason. Do we have a reason already? Hold reason, treasury hold. Yeah, we'll add another one. Codec. Next is one. I guess we will add a new one. Doesn't matter. Cool. Do we have the runtime hold reason already injected? We do. Beautiful. So we might need to do into here. Let's check the signature again. Self reason. Yeah, and self reason will be the runtime reason. So we need to do into here, right? Because we have this our local type, our inner one, and we need to hoist it up. We need to convert it. Yeah, and I'm just now realizing I'm being silly because the who is different, is not right here, because we were saying we want to hold the treasury amount, the treasury account. Yeah, makes more sense. Otherwise, it's like, I mean, in order to demonstrate the API, this would also work, but we'll take the account ID. So self account ID. Cool. This one we won't need for a bit. So normally there would be some sort of permissioning, right? Some sort of check of like that you're allowed to register the spend, presumably. You know, the process would be different for the actual implementation. For right now, we're focusing on the fungibles thing, so the permissioning is not great. All right. This one also needs an into, I think. This one will not be who, it will be treasury account ID. And then I think we're ready to run the tests and see where we go. Treasury. Next test. Let's see. Do you already have like confusions or something about the code I was writing? I can explain while it's compiling, so we're not wasting time. The code is here. This is the test. This is the code. Very simple so far. F invalid palette call require return type dispatch result with post info. Okay. Sure. That used to work. It used to just infer like, I have nothing's there. Expected results. Sure. Also true. Function not found. Is it private? No, it's public. Count ID. Treasury. Oh, hold reason. Yeah, not reason, hold reason. Sure. Hold reason. Tests. Hold reason. Balance not found. Sure, we will need to get inspect hold probably. Use frame support. Let's see, we have it here, right? Mutate hold. And so token fungibles, inspect hold. Not found. And could not find token in frame support. Oh, in frame, okay. That was the wrong library. Okay, asset not found in the scope in librs asset ID. Asset ID. Fungibles, treasury lib. Okay. The trait is not imported. Interesting. That is very annoying. Okay, we also need to use the frame token mutate hold. Fungibles. So we have it required on our associated type, but we also need to import the trait if we actually want to use it. Okay, now the assets. Inspect, mutate. That should be fine. Oh, what? Okay. But I want to be able to hold. I'm just going to add that and see if that works. Fungibles, hold, mutate, reason. Bam. Okay. Arguments to this function incorrect. Expected polka inspect balance. Found fungible inspect balance. Fungible expected balance. Ah, yeah. Okay. Yeah. So this was where? Hold. Right. So here, right, this is where we get into the thing that I talked about earlier. I have a parameter of type balance of t, but I'm using the fungibles, and the fungibles expect the asset balance of t or something. And so because I added the where clause, I should be able to just convert. Registered unsatisfied trait balance from is not for runtime hold. From hold reasons. Okay. My guess is we'll need to add a ref. And then probably the same here. It's based on references, I guess. never compiles on the first try. So unsatisfied trait bound. Required this one fungibles, mutate. Huh. Also question for the instructors. Does assets not implement fungibles mutate? Fungibles hold mutate?
It should.
It should, right? That's what
What's
I would
the
expect.
problem? Satisfied trait.
A trait fungibles mutate hold is not implemented for palette assets in the mock
The
test.
trait fungible mutate hold of U64. Is that an issue?
Yes, there's some.
Maybe the implementation doesn't allow a U64, but I'm not sure.
Yeah, there could be some. So palette assets, the asset ID.
Oh, true, true. Yeah, it doesn't implement hold. It implements inspect and mutate, regular ones.
Yeah.
And then there's another palette called assets holder,
Oh,
and another one, or assets hold, I don't know. And another one
Yeah.
called assets freeze.
right.
It's an example of like extension palettes.
Yeah, the extension
true,
palettes.
true.
Do we? I wanted to show the API. Do we? I guess I pull it in, but
You can use balances, but you want to use with multiple assets, no?
yeah, I wanted to show it. But like, I mean, I guess they don't need it for the assignment if it's not in there. So.
Yeah, yeah, they don't need it for the assignment.
Okay. What do we do?
You can show the code maybe instead of coding it. You can go into the assets hold palette. Maybe?
Yeah, let's just do fungible hold.
Yeah, yeah, that would work.
Remove the asset ID. So I guess we don't have that one. We won't need that one anymore either. Why am I doing into on the amount was the question? So the reason I added into was that I had the balance off here, and then the associated type for the fungible is slightly different. And so that's why. Like there's like, I know that in most sensible chains, they will probably be the same, which is why I added the where clause. But in terms of the type system, they're not the same type. The asset balance and the balance off. And that's why I added the into. That was an easy way.
If we're not compiled, this is my question. Like if I'm removing into, I'm removing it, we're not
Yeah, it will
compiled.
not compile because it will be like, oh, there's one type here, but I expected a different type.
I mean, like it's compiled, but it failed for some reason. I don't know why. So I was guessing like it might.
No, but yours is correct. It has amount is balance of t, and then you do a native balance hold. So that's the right type. That's not the. If you have an issue, that's not the issue. This is a different one. Okay. I'm just going to leave the where clause there for right now. We can remove it later. So we have the hold reason, we have the count ID, we have the amount, and then I guess in the test, we will use balances. Instead, we will remove this one. It's all very sad, but that's what life is sometimes. We can do a transfer or something with an asset ID if you like later. We'll see. Okay. Panhole. Fungible. Yeah, now we have the wrong import, of course. Fungible. And there we want fungible. Okay. Account ID. Not found in palette test with a similar name. Did I typo it?
Yeah,
Account. Oh my God,
yeah.
I forgot a C. Where was that? Okay. Wow. No, wait. Where? In the test. There we go. Okay, in the test. Typing is hard. Reading is harder. Okay, funds unavailable. Oh no. So we will need to print some money. Okay. And then we will do balances, mint into. And we will mint into our treasury account. Treasury ID. And we will mint amount. And I think we might actually do balances, minimum balance plus amount. And then because we do mint, we also need to mutate. And then because it's an account ID, no, I think we'll get a result. We'll see. The compiler will yell at us. Somewhere else. Minimum balance not found. Okay. Need the regular inspect. Of course. I'm going to be very honest with you, is one of the most annoying things when it's like I'm passing a value and I need a reference and I'm like, you're the compiler, you tell me exactly what's wrong. Why I want like a lax compiler that just takes a reference if I need one. Okay, cool. The test's passed. So to recap, what are we doing? We mint some balance into the treasury account, and then we register the spend, and the registering of the spend places a hold on that amount, and then we can check that the balance on hold is the amount that we are holding, and everyone's happy. Questions about this? Extensions you would like to see? Yeah, we probably have a microphone for you, for example, up there in the front. Sorry that you're walking yourself. There in the first row.
So maybe you can tell us a little bit how it works behind the scene, the hold, just a little bit to understand what's happening and how we can use it.
Sure. I mean, we can just balances lib. So we're here in Polkadot SDK. We are in the impl fungible of the balances palette. Yeah? So you can see here, balances palette is where we are, and it implements fungible, and then there should be a function hold here somewhere. There isn't. It's probably the low-level one, right? Yeah, we probably implement the low-level set balance on hold. Right? So you can see if we can find where this is called. There's probably a default implementation somewhere that hold RS. Decrease. Hold. There we go. So we have ensure can, so the trait, the mutate trait. So this is the tokens fungible hold RS. So this is mutate hold, right? There's an alias that calls this mutate hold, but right here it says mutate. This has the function hold. This is the one that we're using. We pass a reason, we pass an account ID, we pass a balance, and then it's automatically implemented based on the lower level functions that exist, which is ensure can hold, decrease balance, increase balance on hold, and done hold, which I guess sends an event or something. So this is automatically implemented based on the low-level stuff. And so then in the impl fungible, which I hopefully can find again, this one here. Yeah, here there should be decrease, increase Maybe it's not even increase and it's just a set balance. Probably there's another default implementation that uses set balance to implement increase and decrease. Let's see. Find that. Yeah, there we go. Yeah. So there is a default implementation for increase and decrease that uses set, and then set is the one that's implemented. So there's, like a bit of distinction between what's the API surface that's nice for the consumer of the API to use, and then there's like, okay, what do we expect the implementers to implement? So there's a set balance on hold, and then what we have in the balances palette is that we have this holds storage item. And the hold storage item is a map where account IDs get mapped to holds, and holds are this vector thingy that has a bunch of reasons and amounts, I assume. Yeah, there's like a little struct in here that has an amount and an ID. The ID being the reason. And so we have this vector of reasons why someone's balance might be set on hold. And so that's what we do here, right? Depending, there's a bit of complexity here, but you get it. What was the question? You wanted to know how the hold works, right? Now you have some idea. Yeah, I just wanted to check back with, yeah. Exactly. Yeah. So I'll commit. I guess I'll add a comment. This does not check any privileges, just accordingly before using in your code. Just a simple hold API demo. Demonstrate how to hold some balance. Beautiful. More questions, confusions, snide remarks? Conflict? What did you do? What did I do? What did you do? Spend big. Okay. Accept both. God, this is one of those moments when it's like, Git, what are you doing? It's like what? Well, let's see if it still compiles and formats. Yeah, of course it doesn't. Oh, come on. The OK is missing. Okay, that one's easy. Okay. Okay. Yeah, more questions. We could, do we need to do math anywhere on the balances? We could demonstrate that.
Yeah, maybe something regarding the weight and the balance for free transaction.
For free transaction. I mean, we already have the balance to weight. And I mean, weight to balance would just be the other way around if you need it. And it basically says like, not my concern, runtime, please save me. We could see how is it implemented? How is this implemented in the runtime? And then if it's not, we could try and implement it. It's implemented. Unique saturate into from all. Okay, I guess that's one way, I guess. Yeah, can you do better than this? Nice, okay. Other questions about the free transactions, maybe? Anywhere you're stuck there, something you want to see from us? What would be good? Let's see. Let's look at the assignments. Multi-token allocations, not enough. Existential deposit, logic. To the weight credit and fee, free transactions. Period sequence. So it's clear that for the free transaction, you might use the freeze, right, to lock up tokens. It's very similar API, slightly different semantics. We talked about this a bunch. To the weight credit. I wonder whether we should implement some of the time tracking thing. Cisco, what do you think? He's deep in thought. I'm like unsure whether to do it. You really don't have any questions? You're all like happily working on your assignments and like not stuck or something? Okay, cool. Have a good cohort this time. Strong. Cisco, do we have any questions from the Discord that we should talk about, or that we?
I've been answering, and Sean as well have been answering the questions, but maybe we can take a look at one of them.
Yeah, maybe one that you're like, that would
Um,
be good if everyone saw that, or it would be good if we elaborated or did a small coding thing around it. I mean, otherwise we can also just spend the next half hour just tacking on stuff. So
Yeah. I mean, I guess whatever people want. Like, if anyone wants something to be shown, we can show it. Else, we can have half an hour of just people doing their assignment.
Yeah.
You have something? Sure. Nice.
I know like we are doing like mostly multisig in live coding, but the multisig, we have to manage the balance, hold balances, right?
we have to manage what balances?
Hold balances.
Held balances in the multisig. Right, yeah, you want to have some sort of deposit, and you would use holds for that, I think. Yeah?
Yeah, I mean, maybe we can see that. I know. It would
Maybe
be
we can
useful
see that.
for- Yeah.
How to take a deposit?
Yeah, and how to use it.
Okay, thanks for the thing. I think I will answer very, very shortly. Because like, okay, here we use the treasury account to hold it. And if you want to do a deposit, you would just do who. You might give it a better name, like
Yeah.
deposit, and that would basically be it.
Okay. Interesting.
The only thing is, like, you might have some, like, a thing that can happen is you might need to hold, like, a bigger deposit. So let's see. You might need to hold a bigger deposit, so you might want to check kind of balance on hold for this account. But even that, like, I think the hold is additive, right? Let's check the API. The API. Hold some funds already in places will increase it. Okay, so actually it's fine. You don't need to. Yeah, it will just increase the hold if you already have some. But then there might be a point where you need to check, like, oh, how much do I have on hold? I don't know, maybe, yeah, but yeah, you might be able to just release it. Yeah, should be fine. Like when you refund the deposit, you release. Then you have, like reason, who, amount.
Okay.
Let's see.
Yeah,
Can I
thank
ask
you.
a question here?
Yes, you can
Yeah,
ask
like
a question.
if I have like amount of token already on hold and I want to increase, like I have to call increase, or I can call hold and it automatically manages the.
Yeah, maybe you cannot see this because it's not big enough or something. So we just checked. The hold increases it for the same reason. So it's additive. Yeah. And release will, it will reduce about the amount that you see.
Another question. When we call like amount on hold, it will calculate all the amount on hold, like assuming that I'm staking, like letting him to lock his token, and someone else, like other pallet or whatever, the same token is locked as well. Is there any differentiation between?
Yeah, there is between
Like
the
the reason?
reasons. That's why you give your own reason, because it gives you, so you can get the total balance on hold if you want, but usually what you will do is, oh, I care about my pallet, and my pallet will have its particular reason or reasons, multiple, yeah, and so then you will only get those ones. I think the fungibles APIs, there's like a lot of traits and stuff, so that can be a bit confusing. But I think the API itself is quite good because it's the second version, and it's quite well thought out. Okay, then I'm leaning towards just wrapping up for right now, and then if a question comes up, Okay, Sean, you have a question. I cannot quite hear what you're saying. Let's get your mic.
The last PR you pushed, the way you did it is not the best solution. It's actually breaking the benchmarks right now. If you run the benchmarks, and this is because you put a where clause, and it's better to keep the constraints up in the config or to just make the types the same. Like if you right now the benchmarks, you just introduce like a constraint.
Yeah.
At the wrong level, I think.
Okay, we'll see. Good catch, if that's true.
There is a really easy way though to, I think, do what you want. I think that's also maybe good to show. It's like very fast.
Yeah, cool. Let's, I mean, we can already look at it. So where did I put it? It was in Treasury, right? So I put it on the call, and you're saying on the call is not the right place?
Putting that where bound there is like, yeah, it's not, I think it's not the right place.
Where would you put it?
I put it in the config, up where we define the native balance of fungibles. And I would just simply, if you want those two to be the same type, I would just simply assign those two as the same type up in those traits. So I would say like,
oh, you mean like here?
Yes, like similar to that, yeah. Like balance equals, or like maybe in the fungibles, like,
in the fungibles.
Yeah, then I just say like that balance equals balance of t or self. Something like that. Because the way that you do this where bound stuff, it like it doesn't know that it can resolve in the benchmark.
In the benchmark specifically. So I would need to add the where clause in the benchmark as
You
well,
need to
right?
also add the where clause in the benchmark.
Yeah, because there are cases where you can't do what we just did here, which like you're right, in this particular case, that's probably the way to go. But there are cases where you need to add a where clause to the impl block, right?
I mean, this is even stronger, right? Like this is like, if you put something up here as a constraint, it's stronger than putting it as a where clause lower in the palette. Because this is like,
yeah. No, I'm saying you're right. For this particular balance thingy, it's the right way to go. But there might be other cases where, like, I don't know, like while debugging, you might add a debug.
All the constraints should be up in the config. That's like the place where you have the constraints over your palette. Like all the trait definitions, all the type definitions.
Okay.
I mean,
all right.
What you're doing is also like okay, but
it has the disadvantage that it will break the runtime benchmarks if you don't check. Yeah, got it. Not found in this scope. Yeah, because it needs to be self. There is no T. There is only self.
So this what's happening here is really powerful, actually. So I think it's worth calling out. That.
Yeah, and like I can explain what we did, right? So you've already seen this reason is self runtime hold reason, right? So there's a Rust feature where if we expect a trait somewhere and the trait has associated types, in this case it's the reason, then you can, when constraining to that trait, you can also constrain the associated types that are on that trait. So in mutate case, there's the reason, or for the inspect, mutate, and create, there is the balance associated type, which is the whole reason why we have this asset balance off here, right? It's going into the fungibles, which is this here. It's going into the fungibles, treating it as inspect with this account ID, and then it's accessing the balance associated type. So this is kind of like, oh, I have some kind of generic type that depends on T that is under this path kind of sort of associated types of traits path. And this is kind of saying like, I want whatever that type is, I want it. And then this here is sort of kind of doing in some sense, taking a type like that, like this, I want the type over there, the balance of t. And this is doing kind of the inverse in a sense. It's constraining the type. So this basically ends up saying that, balance of t kind of equals, not quite equals, but equals asset balance of t, or like, is type or something. I don't know. This is a pseudocode anyway, so who cares? But right. And Sean is right. Whenever you can introduce something like this in the config, that is a good way of kind of constraining your types, right? You could also go and be like, I want runtime hold reason to be encodable, or yeah, whatever the things are. Okay, cool. This should compile. It does. Move balance type constraints into config trait. All right, now we'll code. And if you have more questions, I might go back up here and show it.
I recommend just for all of these hashers, you should put link to 128 concat. That's my recommendation. And so basically like go back to the story vectors. Basically these hashers are being used to determine what keys are. You get that, okay? So then it's basically don't think too much, just put like 213 cat. I even replace this with like 213 cat. That's key 1, key 2, and the type. Yeah. Yep. Yeah. Make it all like 213 cat. Yes. What's up? Let's look up see. Okay, that's fine. So this is people who already selected, or these are like the potential?
Potential. People who want to register basically.
Yep.
They register there. And then there will be a map of block ID to validator account ID. Is it okay to keep this map here?
So okay, this is interesting. So what this is the block number, and this is the validator.
Yeah.
I think again you're thinking too low level. Your job in the D your job in the D class is more simple. That is the same confusion that was coming up in the conversation. So there is like there is something here which is like babe plus aura or babe slash aura, which is the block function. Then there's like grab block. And then there's staking. Okay. So when you're doing like actually creating the blocks, that's happening in this area. You don't care about that. All your job is and all this stuff needs is this one. It says like these two. They say give me 100 people, give me 100 validators, right? And it will make all the choices. It will figure out who builds the block, who builds the stuff. Your job is just to make a list of 100 validators. No order, no block association, whatever. And your job is to update this list of 1,000 validators and update it. Refresh it every 24 hours. So all your job is to make a list of 100, 24 hours, calculate new lists. The list could be the same for all people. It could be the same. You have to recalculate. Just give a chance for a change, and send once every 24 hours to this function the validators. We say send it. All you have to do is call this function that we gave you. In the function, we have this report to validator set. That is what this you're reporting to validators. So once you have the list of so we have here there's 1,000 people who register. Then there's voting, and then we calculate from voting 100 winners.
Good.
And then all you do is call that. So your job is nothing past this. Your job is just collecting the vote registers, getting the votes, and calculating the winners. That is the now.
So then I can remove this.
Yeah.
I was keeping this because I wanted to answer who's the author for the particular block, where I should distribute the rewards.
And actually, I think you can give so that's reasonable. Okay, sorry. Then what you're doing is reasonable. I think that you keep it simpler, and you can just give a reward every block. So instead of tracking it and calculating it later, you can just
Here itself.
Yeah, directly on the block, on initialize. Here's the reward. Kind of like I think we had that example, right? On initialize, who's the author? Give them a reward. Mint it to them a reward. So this I think is a This could work more advanced. My recommendation is
Got it. So I'll just mark it.
new block. Yeah.
All right. So the registration will happen through register account ID, and it can give whether the account ID is disabled or does not have sufficient funds. I'm assuming that they are also taking some funds, but then I guess again this is not out in the scope, right?
You don't have to. Yeah, you don't have to. I mean, normally they would self-stake sometimes, but you don't have to do it. Okay.
So I don't have to check whether they have enough funds or not.
No. Okay. And if they can follow your function, then you're good.
Okay. So
Also, the question I would ask you, like, if you have to check enough funds, how much is enough funds?
for staking, whatever is the,
Yeah, okay. If you want to add this, that's your choice. But I don't think
I want to add
yeah,
it now.
yeah.
Okay, so register and then choose validator. This is basically the voting
The
part,
delegation. Yeah.
the delegation.
Yeah.
Yes. And you said that this has to happen every n blocks. So how do I simulate that? Or do I assume that they will call it every n blocks?
No. So what you should do is people make their votes, and people vote at different times, right? So your job is not to make everyone vote every time.
Okay.
If they make a vote and they don't change it, the vote stays. But your job is to recalculate with the latest information every 100 blocks.
Where exactly?
Or whatever.
In which function is that
That would
supposed
also
to
be like an uninitialized. So then
Oh,
what we just
okay.
shown here, maybe you can ask in the chat. What
Got
we should
it.
do here is like,
If it is n
Yeah.
plus 100,
yeah, exactly. So we
Then
just n, yeah, and if it's n odd 100 equals 0, right?
Correct.
then we do the recalculate on
Correct.
every 100 blocks. But that's the thing, like, like think about a blockchain. It's just running, and people are voting, taking away votes, or voting whatever. All these changes are happening, and then you say, okay, 100 blocks. Let's calculate what the situation is.
Okay, so I don't need to simulate this. Report misbehavior. I was thinking I'll export this function. Report misbehavior for account ID and add block number.
Sure, that's an option, right?
It's optional.
Yeah. Okay.
I mean,
I want you to. Okay. Yeah. So sorry. Tell me what you're thinking, and then yeah.
no, so I was thinking how to access. How do I verify that the person actually misbehaved by?
Right. Again, it's not your job.
Not my job.
So your job is you're the money manager, right? You just care about the money. These guys will do the consensus. They will report to you. So you have an API to tell them, here's the new validators, right? That's what this validates. They have I want you to make an API for them to say slash, right?
Okay.
And you don't care why it's your staking palette can't know all the rules of consensus. All it says is my boss told me take away your money, and my job is to take away your money.
Okay.
And you're the person who's in charge of all the money, so you know how to update the balance, all this. So your job is not like your API should just simply be like slash some of that, and then amount, right?
And then
your job is just to like take away their money, make the balances less, and update this again. And see, maybe you even kick them out, right? Like if they were validator and they get slash, kick them out, right?
I was thinking more like keeping them disabled or blacklisted.
Okay, sure.
Okay. So report misbehavior for account ID at block number does not matter. Amount, is that something which is fixed or it is constant?
It's a good question. It's up to you. I mean, it could be a percentage. It could be a number. Like the type you use is kind of up to you. I don't think I really care.
Okay, so essentially there is no check that actually happens. I just call slash, which calls withdraw funds or transfer funds, and that's it.
Basically, but also not only just withdraw funds, but also these people so right now the way it is that you have a validator, potentially no money. You have delegators who are voting on a validator. When you slash, you have to reduce everyone's funds, right? And then you have to update how much they're staking, right? So something like that, right?
By everyone, you mean all the people who voted for that person. And if no one voted for that person, they themselves must have staked some fund.
That's the thing. So if no one voted for that person, they will not be in the winning set.
No.
Hopefully.
By voting, you mean someone delegated.
Delegated, yeah.
And if no one delegated, let's say no one delegated to no one. Everyone is in for themselves.
So you should handle no one delegated to anybody. So there's no money in your system.
No. There is money, but people are themselves
delegating to themselves.
Yes.
Okay.
So in that case, the flashing
Should be for stuff.
for them.
Yeah,
So
but
anyway, the transfer function calls it happen in that case.
yeah. But the thing is, the way your function should be written is that there's some validator who's slashed.
Okay.
All the people who have money behind that validator should get slashed. Right? So whether it's the validator, or the other delegators, all of them should be slashed, right?
Okay. Yeah.
Because all of them should be punished.
Then I should also remember list of delegators and the map of
Validator delegate.
Yeah.
Yeah. So this is another.
delegator.
Yeah.
So the signature of the map that you have given, I mean the definition of the map that you have given,
Inside of
in the depos lib,
we gave you something.
yeah, we should be doing something.
Like
Something this one. It says account ID and account ID and block number. This is dummy, right?
yeah, something.
Okay.
Something. This is just
Got it.
some code that doesn't do anything.
So one question here, let's say one validator gets 5 votes.
Okay, sure.
Five.
5 delegations.
Yeah, 5 delegations. 5 delegations point to the same validator. In that case, if slashing happens, all 5 of them, the money will be gone.
Sure.
And for this person, nothing should happen because they did not put their own money.
Yeah, I mean, but probably you want to do what you said. You banned them, right? You kicked them out.
That I'll
Okay.
do. But
Yeah.
for the transfer function, I should invoke only for these.
Yeah, exactly.
Okay. So report message user is fine.
Yeah. So for example, one of the things you can do to make your system simple is if I'm registered as a validator, do not allow me to be delegated. So you never have a problem where,
Oh, okay.
does that make sense? Like you can make the rule, like it's your blockchain.
Okay.
You can allow a validator to vote for himself, right? But then you have to check, I don't know, there's extra checking or maybe, right? You could also make it so that when a validator is validator, you can't be a delegator. And if you want to give money behind you, you have to make 2 accounts. That's okay.
Got it. But then this is the basic premise of cyclic delegation, right? You have a validator, people are delegating to them, and they may also try to delegate to them, or they may try to delegate to another validator who can try to delegate to another validator who delegates back to this person.
So you can solve this by not allowing validators to delegate, and only delegators to delegate to other people. I mean, there's still going to be cycles.
So you're saying validators cannot delegate within themselves, only users can delegate to validators.
Yeah, and only delegators can delegate to other delegators. So that's what that- then you still can have a cyclic problem.
Yeah.
But that's not your problem. As long as, how do you say, like, it's not really, like, when you design a system, if the cycle happens and no one gets any votes, it's not like a illegal thing.
Okay.
That makes sense?
It shouldn't happen to them because
I mean, users don't want to do nothing with their money. But it's not like it, like, I mean, like, if you, ideally, your logic does not break as long as using a cycle. Right? Like your logic, like, if I have 3 pointers and the pointers are pointing to, themselves, like, this is weird, but it doesn't like stop the rest of the program from running. Right? Obviously you shouldn't loop through, like, if you have some kind of loop where you're waiting to find valid, that's going to be bad, right? You shouldn't have that kind of code. By the way, slashing and this, I think each take as much time as the main project.
yeah, that's optional.
Yeah, I'm just making sure that you don't get lost in the weeds.
Yeah, but I'm not making perfect project either, so I do iterative coding. So, but then if we don't allow validators to delegate, then the cycles will never happen.
They can happen because you can have a delegator vote for a delegator, vote for a delegator. Because the way that we do the nested delegation is that I'm a delegator, I delegate to you. You're a delegator, you delegate to all of them. Yeah. But if you delegator plus delegator plus delegator, then it's weird.
Oh, okay. And this person can delegate to this person who can delegate to this.
Yeah, and that's the cycle.
Got it.
But it shouldn't be just it doesn't break anything. It just
Okay. Last question, I think. To distribute the rewards, that should happen on initialize. Okay. So yeah, is there any other function that should be there to complete the requirement, or this is good enough?
Yeah. So here are the functions I think are in my head. There should be an uninitialized function. It does the rewards and it does the update, right? Every
Okay.
there should be a register to validate. E-register to validate.
Deregister?
Yeah, people can quit, right?
Oh, okay.
You want like once I validator, I'm validator forever. I say I don't want to do that.
I thought the registration was only for the next 100 blocks or whatever is the value of that. So you register every 100 blocks.
No, you don't have to register. That's
Okay.
that's like that is not like the well-running system. Like your system, if you have to do everything every 100 blocks, it's like everyone has to keep talking this thing. If the system, if someone's registered validator, they just run it. Yeah. How much like do you have? Are you familiar with Ethereum? Are you familiar with like other blockchains?
Yeah,
Solana?
I'm familiar with most.
Yeah, so
Yeah.
for example, that if I went to Solana right now, same validators you knew 10 months ago are still there today.
Right.
You don't think they're like registering every time. The state is there that I'm being a validator and the system checks. You don't have to reset everything. Right?
Got it.
So actually, I imagine there's register. Then I get if you want, if the validator wants to quit, imagine there's deregister.
Yeah.
I imagine there's a delegate. Imagine there's an undelegate.
Yeah.
I imagine there's a function called like get my rewards. Or maybe there's not
You
because
mean
you're doing it
claim?
automatically. Yeah, claim rewards, but you're doing it automatically, right? Too. So it's fine.
Okay, so I won't put it there then.
Yeah, yeah. What else? Delegate. Most of it. That's usually what I mean is maintaining that is not trivial.
Yeah.
Yeah. It could be, you know, like other functions. Like if you want to add like next levels, like the validator can say how much they want, how much reward percentage that they take for themselves. So usually there's a commission.
Okay.
So maybe when I register for validator, there's a commission amount, but that's extra. Like,
Who is it to decide that this is okay?
no, that's the thing. So the validator puts, I am a validator. I will take 10%, and you will vote for me. You know, I'm a validator. I say I'll take 100%. You're not going to vote for me, right? That's the thing. These systems, it's not like your blockchain has to make all the rules. Like people make decisions about their life, right?
Got it. So maybe in the register itself, I can say that, hey, this is my account ID.
And,
And
how
then-
much I want to take.
Minimum I
Yeah.
want 10%. And in delegate, I can say, delegate will be successful only when you're okay with the 10% condition. So here,
It's not. You don't have to say okay. You delegate. Like when you delegate, you
okay.
are aware of who you're delegating to.
And by default, that 10% will get cut even if you don't want.
Yeah, you have to. I mean, that's the rule of the delegation. Like, I'm delegating for a validator. However they configure is I'm voting for them. Like again, this process isn't blind. It's not like I'm just randomly picking people. Like the process should be like I go to some place and I'm making decisions on where I'm putting my money, who I want to stake, right? Like there's all the time you see ads on Twitter. I'm staking with finance 10%, staking with Coinbase 12%. Everyone's trying to fight for you to give them their money. And to hear validators would be like, I would be a high quality validator, I'll give this much money, like all that stuff. The user and all of this is verified on the blockchain. The blockchain registers this information. So
Got it. And reward distribution. So, let's say this validator gets 10%.
Yeah.
And let's say 5 people delegated to them.
Yes.
So the remaining 90% will be divided between those 5.
yeah, but it should. So now the simplest thing is it's divided evenly. That's
Yeah.
usually not the correct way. You should divide it proportional to how much they voted, they delegate.
Which depends on their voting power, which depends on their token.
Which depends on how much they delegate, how much they lock, how much they take. So
How do I get that now?
So that's the thing. When I do delegate, you don't just delegate no input. I delegate how much do you want to delegate.
Yeah, but how do I verify that they actually stake those many tokens? Because I don't have staking logic, right?
No, that's the thing. You are the staking cut, so you should. You are creating a DPLOS system. You will create the staking system. Your job is this. Your job is if the user says delegate to this validator for 1,000 tokens, right? Your job is to check inside of the balances that you can hold 1,000 tokens, right? So state, yeah. So state how much, and we call hold for that, and this function can return an error.
Yeah, this part I understood.
So if they don't have enough money, then
Yeah, that part I understood. But earlier I discussed that in register function, when I'm registering, I'm also
validate.
okay. So there's a register for delegator, and there
There's a delegate function,
okay. So there's a delegate function, and that also stakes the token at the same time.
yeah. I mean that's generally how it is.
Okay, so the tokens. Then I'll have to remember
It could be 2
the.
steps. However you want, it could be 2 steps.
Okay, so then in the storage, I also need to remember who delegated, which delegator had how much to stake.
Yeah, exactly. Yeah. I mean, there probably you're gonna have a struct, which is like delegator info, which has like a bunch of information, who they're delegating to, how much they're delegating, where did they start delegating, like, right? And also be a validator info, which has like what's the percentage of amount of commission, all of that stuff, right? So again, I know the staking palette is big, right? So maybe it's big to read, but like all these ideas do exist there. Yeah, let's see. If I go like delegate escape, palette, delegation. Right. I didn't know this existed. Yeah, so you have like the delegation delegators is a map from the account to delegation. Agents, their ledger. Okay, so here, so now let's look at delegations. There's a delegation. It's like who the person is, the target, who am I delegating to, and how much am I delegating? That sounds exactly what happened, right? And then, okay, now I have the agent. Where's the agent information? Agent information. It's like, where the reward should go. What's the total amount that's delegated to them? How much have they done? And any like, the ideas in here are like, I mean, this is probably a lot more complicated, but like, and if we go to even staking, so staking palette, so the original staking, I didn't realize that we had this delegated staking, but it's staking palette. If we go to here, it's just palette storage. I'm sorry.
Okay. I hope you had fun hacking. It's 12:30, so time for makan. Time for some food. See you later in the afternoon at 1:30, I think, right? The afternoon again will be light coding and hacking. So feel free to come here to hack together, or yeah, we might do, if you run into issues, we might do another hacking session. Yeah, see you later. Gather questions. Come to us if you have problems. Now's the time to. Yeah.